Okay, we're going to prove figures are similar and use the definition of similar to solve problems. So image, that is our second figure. After the transformation. The pre-image is our original one, the first figure, the original, before the transformations. Before we transformed it, that's what it started at. And our scale factor is image over pre-image. New over old. Or new over original. Okay, then last year in Math 1, you guys learned about congruent figures. Two figures are congruent if and only if the second can be obtained from the first by a sequence of our transformations here. So we have our different transformations or rotations. What's another transformation? Translation. And there's one more, Tejas. Reflection. Okay, those are the ones you guys learned last year. Those don't change the figure at all. They just move it in a different spot. It just kind of moves it in a different location. And that created congruent figures. In Math 1, we discovered that we only need 3 parts to guarantee the 2 triangles are congruent. Do you guys remember side, side, side congruency? If all the sides were congruent, then we could say that the triangles are congruent. Okay, angle, side, angle. If you had an angle, then a side, and another angle, then you could prove that those things were congruent. Or there was 2 others. Yeah.
Side, angle, side.
Side, angle, side. And there was one more, a very special one. No. No, that was not a good one. It only worked in right triangles. HL, I heard someone say it. Who said it? Who said HL? And HL, which is hypotenuse leg. No, side angle is not an option. We already have angle, side angle. Angle, side angle. Okay, so those are our different ways to prove triangles are congruent. So we want to prove these 2 triangles are congruent, okay, by transforming them. Since I don't have any measurements, I'm going to transform them. So my goal is to get ABC over triangle DEF. Any ideas on how I can do that? Yep. Ooh, reflect across the y-axis. So let's see if that works. If I reflect across the y-axis, then it's just going to be, A is going to be over here. So we have 2 over would be B. He wants to reflect across the y-axis right there. And then A would be, let's see, 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5, 6 away. And then C is 1, 2, 3 away. And then 1, 2, 3 away. And then if I reflect it across the x-axis, then it'd be down here in this quadrant. Okay, we could do that. Okay, so let's do that. Now we're going to reflect across the x-axis. Is that what you said? To reflect across the y and then reflect across the x?
Yeah.
And then we'll move it up. Okay, that'll work. So then we would get 1, 2, 3. Let's do this. 1, 2, 3. So down 1, 2, 3. C prime, double prime now. And then up 1, 2, 3, 4, 5, 6, 7. So we go down 1, 2, 3, 4, 5, 6, 7. And that would be our A double prime. And then here would be up, that's up 7 too. So we down 1, 2, 3, 4, 5, 6, 7. And that would be B double prime. Okay, so let's write down those two things we just did. Number 1, sorry, the y-axis. That's what we did first. And got triangle A prime, B prime, C prime. The next one we did was reflect across the x-axis and got triangle A double prime, B double prime, C double prime. Okay, now what are we gonna do? Move it up. How much? Up 7, okay? So the third step would to translate up 7 units. So that would give me my B on D, my C on E, and my A on F. Does that make sense? So now we can prove those two triangles are congruent. So I can say that triangle A, B, C is congruent. What corresponds to the A point in the other triangle? F corresponds. A and F are in the same spot, right? The same angle. To triangle F, what corresponds to the B in my new triangle? D. And what corresponds to the C in the next triangle? E. Again, it really matters that you line up the corresponding angles. Any questions over that? Yes. We could have done this in a different way, yes. You can do different transformations to get it there. Okay, so if you didn't do the exact same ones that I did, that's fine. You have to prove it your way. Because I wouldn't have done it that way, but it worked, right? I could prove it that way. Okay, so again, you don't have to prove it all the same. That's a little bit tricky about geometry, is that you can have a couple different ways to get there, but this works. Any questions over that? We're good? Okay, similar figures. Now, two figures are similar if and only if the second figure can be obtained from the first by a sequence of rotation, reflections, translations, and dilations. Now, can we prove these? Again, we want to transform ABC and make it fit onto FED. Any ideas on what we can do? Okay, I wouldn't dilate first. I would dilate that last on this kind of grid. Okay. Can we get it lined up another way? Because this center of dilation won't be on the grid. So that wouldn't be helpful for us at this point. No thoughts here? Yeah? Okay, so move it right 6 units. 1, 2, 3, 4, 5, 6. Get what? B to E. Okay, so go over 1, 2, 3, 4, 5, 6. Very good. So we want B on E. So this is also B prime. And then I'd have to move to C also over 6. 1, 2, 3, 4, 5, 6. And this is now C prime. And then move over 1, 2, 3, 4, 5, 6. This is A prime. Okay. So our first step is to translate triangle ABC over, or sorry, right 6 units. Okay, you kind of want them to have a common vertex, a common angle, because you want to put them on top of each other at first, and then that's an easy way to dilate it from there. Okay, you kind of want to put them over each other so they have a common vertex, because then you can have the point of dilation. Now, how much would I have to dilate triangle A prime, B prime, C prime to get triangle DEF? By twice as big, right? The second step. Dilate triangle A prime, B prime, C prime by 2. So now from here to here, that's 1. Oopsie. That's fine. I don't think it's there. Nope. There we go. Nope. We just lost it. Let's see if I can undo until we get to it. Oh, there we go. Can you wait till we're done with this? So we want this side This is 1. The rest of it's 2. So to get this here, we have to dilate it by 2. And so that would be C double prime. Same with this one. Here's 1, 2, 3. So then 1, 2, 3 would double it. Does that make sense? So this would be my new A double prime. And then B doesn't have to change at all because that's my center of dilation. Okay. And I should put that. Dilate triangle ABC by 2. From B prime. The center point of B prime. Any questions over that? Yes. Very good. We're going to do that right now. So we would say triangle ABC. That is similar. Just the top part of the congruency mark is similar to triangle. Okay. What angle corresponds to angle A in my other triangle? D. What angle corresponds to B, E, and F? This is our similar. That's the similar symbol. Any questions over that? Okay, next one. So we want to determine if the following conjectures are true. Are all rectangles are similar? We want to explain. Okay, so everybody draw a rectangle. I'll draw a rectangle. Oopsie, undo. How do I know that's a rectangle? Because what? One side, they have parallel sides, right? Opposite sides are parallel. Okay. And opposite sides are congruent. That's the definition of a parallelogram. What makes it rectangle? 90-degree angles. Okay. Okay, that's how I know all the angles are 90 degrees. That's what makes it a rectangle. Okay, now I want you guys just to tell me what you think those side measures. How big is this? How big is that? You guys write something down. They're not gonna all match. You just get to label whatever you want. Label the sides. How big are they? Okay, write that down. Okay, you're gonna pick yours. I'm gonna pick mine. I'm gonna make you pick yours first so you don't just copy mine. Okay, I'm gonna say this is 2 and this is 5. Okay, well that's not gonna be helpful to my lesson here if you guys all pick the same ones as I did. Let's pick on somebody who has a different one than mine. Let's try that. Go for it. What did you put? 10 and 4. Okay, so yours is bigger than mine. $10 and what? Oh, sorry, we have to erase that. The 10 should go here, right? And 4. Oh, well, that doesn't help me any. Because that is similar, right? What's the scale factor there? Right? This is doubled, and all the angles are congruent. Because remember, our definition of similar was that all the angles are congruent and the sides are proportional. Okay? So let's try a different one. Somebody else. Yes, what'd you have? 2.5 and 1. Well, you did it again. 3 and 5. That will be better. Are those similar? No, because the sides are not proportional, right? We want to see, is 2 over 3 equal to 5 over 5? No. 2/3 is not the same as 5 over 5. 1. They're not equal. Remember, therefore, no, the proportional sides. The sides are not proportional here. So therefore, all rectangles are not similar. Any questions over that? Okay, we do the same thing with a square. So everybody draw a square. Okay, how do I know a square is a square? All the sides are congruent. That's one part of it. What else? All right angles. So we have all congruent sides and all right angles. They have to have both. Okay, so you guys pick the measurement of your side of your square, and I'll pick the measurement of my side of my square. So my side's going to measure 4. And again, since they're all congruent, they're all 4. Okay. Kyle, what was your measurement of yours? You did 4 too. Okay, let's get a different one. Tejas, what did you get?
6.
6. Okay. So yours is a little bit bigger than mine. Let me put it up here though. Oopsie. Six, 6, 6, and 6. That is a 6, sorry. Okay, so are all my sides proportional here? Let's see, 4 over 6, does that equal 4 over 6? Which equals 4 over 6, which equals 4 over 6? Are all the sides proportional? Yep, they all have the same ratio that reduces to 2 over 3. So the scale factor here is 2 over 3. So are all squares similar? Okay, who picked a different number than 6? Yep. 1.5 billion. So I have 4 over 1.5 billion. And that's equal to 4 over 1.5 billion. And it would keep going, right? Are all those equal? All those ratios equal? Yes. So our scale factor would be 4 over 1.5 billion. Actually, we'd have to reduce that, but we're not going to deal with that right now. Okay? Because we don't like decimals in our fractions. But for this case, we'll do that. Okay? So, yes, all squares are similar because it only has one side length, right? All squares are similar. Any questions over that? We're all good? Okay. Equilateral triangles. Adrian, what does equilateral mean? All sides are congruent. So I'm gonna draw a triangle that have all the sides congruent. If I can. Do I know anything about my angles of an equilateral triangle? All the same. If you have an equilateral triangle, then it's also equal angular. That means all the angles are also congruent. So this is congruent to this, is congruent to this. And then what would be the measure of each of those angles? 60 degrees, very good. Since they're all congruent, how many degrees are in a triangle? 180, right? And since all the angles are the same measure, you have to divide 180 by 3, and that gives me my 60 degrees. Okay, so all equilateral triangles have angles that are 60 degrees. FYI, if you didn't remember that. Okay, so so are all these going to be similar? Yes, because it's just like the square, right? Since all the angles and all the sides were congruent, okay, that means my triangles are also going to. Because if I have, again, I'm going to say side length of 5, and I draw another equilateral triangle. Oopsie, that was not equal. Yes, let's try that again. Again, all of these will be congruent, and these will all be 60 degrees. So all the angles are congruent. And our sides, let's say this is 8. So my scale factor would be 5 over 8 is equal to 5 over 8 is equal to 5 over 8. And those are all congruent, right? We're good. Okay. Do the next one, rhombuses. Mm-hmm. Do rhombi.
That's a nice word. How does a rhombus look like?
You guys remember what a rhombus is?
No.
What it, okay, well, that's what it looks like. How do I know? What's the definition? It's a parallelogram. That's correct. But what makes it a rhombus and not a rectangle or a square? I'm sorry?
Not all angles are equal.
Not all angles are equal. Like parallelograms, opposite angles are congruent. Okay? What is the other reason? What's the difference between a rhombus and a parallelogram? All sides are congruent. It's a square tilted. Okay? So if you draw a parallelogram, a rhombus is a parallelogram where all the sides are congruent. And then this angle is congruent to this angle, and this angle is congruent to this angle. So we can have the side length of, I'm going to put 7. Oopsie, I just made that wrong, right? I put too many little congruency marks there. Fix that, you guys. This one is congruent to this one. They're not all congruent to each other. Opposite angles are congruent. Okay, so we're going to draw another one. Okay, try this again. Here we go. It's gonna take the 6 with me. Okay. And I'm gonna say these are all, it's gonna be harder to, I don't like that picture. I'm gonna draw a different picture. Makes it easier. That's a really good rhombus. I'm gonna say it's a rhombus by saying all those sides are congruent. And what do we want our side lengths to be?
9.
9. Okay, let's do 9. I do have the same scale factor, right? What would my scale factor be? Would be 7/9. Okay. But what's the other thing it needs to have? Congruent angles. Okay, are those angles congruent necessarily? Does this angle congruent to this angle here? I don't know. It doesn't look like it, but it's not for sure. So I haven't told you that. I don't know the measure of that angle. With the square, I knew that those angles were both 90 degrees. With the equilateral triangle, I knew that those angles were both 60 degrees. With this one, I don't know what the measure of the angles are, so I can't say. So they're not similar. Not all the corresponding angles are congruent, so they're not similar. Any questions? Because they need both sides to be proportional and all angles need to be congruent. Okay, we're going to skip these next two and go on to these. So I've now told you that triangle ABC is is similar to triangle DEF. We want to come up with 3 different ratios as a result of that. So my scale factor would be what? So let's start with AB. AB is 7. We need to find what corresponds to AB in the other triangle, and it's the first 2 letters, DE. So that's over X. Then we want to see what corresponds to BC. Is 4. And the corresponding would be the EF, the second 2 letters. And then the last ratio then would be A to C, which is 5 over D to F, which is Y. Any questions over that? So that is our different ratios, 7 over X, 4 over 3, and 5 over Y. Then we could find the missing angles, or finding the missing sides, by doing 7 over X equals 4 over 3. And cross multiply. So this times this and bring it down. And then this times this equals 4x. Divide by 4, divide by 4. And I would get x equals 4. I can go into 21 5 times with 1 left over. It'd be 0.25. It'd be 1/4. 5 and 1/4 is 5.25. Not sure? Get a calculator, divide it. Any questions over that? We're all good? Okay, we need to do this next one really fast. Oh yeah, we have time. Okay, so we're gonna do the next one. We need to find what corresponds to each side. And this one's a little bit harder to identify because there's so many little shapes and angles. So again, you want to see what corresponds. Let's do BC because AB doesn't have a side length. So BC are the second two letters. The second two letters in my similarity statement is NM. So you need to do 3 over Y. The next one is CD. The next two letters. So it's the third and the fourth letter. So the third and the fourth letter here. ML. So it should be 2 over 4. Any questions over that? Then the next one is E and F. EF are the last two. So an E and F should go with Q and P. So it'd be 3.5 over X. Any questions over that? So that would be our ratios. You would have to reduce the 2 over 4. So you'd have 3 over Y equals 1 over 2 equals 3.5 over X. Okay, your homework is 7.2. Any questions? Okay.